this is how I would learn data engineering if I had to start over. Hi everyone, my name is Eugene and I'm a data engineer. In this video I'm gonna share with you a roadmap that I wish I had when I started my career in tech as a data engineer 5 years ago. The first thing I suggest you to learn is Python. High-level dynamic programming language that is widely used in the data industry. Data engineers use it, data analysts use it, data scientists use it. Almost everyone who works with data uses it. And specifically data engineers, because as a data engineer you'll build tools to build data pipelines, and often Python is a go-to language to build it because it's clean, it's simple, and you can develop very quick with Python. And also worth mentioning that it's very beginner friendly. So if you're just starting out, Python is definitely the best language if you are trying to get into the data field. Next, once you know the fundamentals of Python, I mean like basic programming language, things, functions, classes, loops, all that stuff, and you're comfortable with it, only after that you should start learning data processing library like pandas or polars. Both of them are very nice. Pandas is like an older library that exists for a long time, that has a huge community, a lot of services already use it. Polars is a little bit newer, but yeah, kind of faster than pandas and like the cool kid on the block. So I would say feel free to choose whatever you like, and both of them will deliver what you need at this step. And while learning any of these libraries, you will improve also your Python knowledge. You'll get an understanding of concepts like data processing, data cleaning, data frames, what are they and why are they good for processing data sets. And you will be able to already do some data projects, small and big. So by these projects, I mean like you can download some source raw data somewhere from Kaggle, or like just Google data processing projects, and you'll find many places where you can get sample data for your analysis. Then you'll need to clean it, and drive some insights. And it's actually interesting because analyzing data is fun, and you might get some not obvious insights from it. Just go slowly, take your time, get a good grasp of Python and one of these libraries. Do several small projects of data analysis, and then try to think or try to find some bigger amount of data. Basically do the same that you did for the small amount of data, like several gigabytes of data, but this time try to find something bigger, like 20 gigabytes or even more, and try to extract some insights from it. You'll face an issue that you're just not able to process this huge amount of data locally on your computer. And this is a good point that lets us to connect to the next node in the roadmap. And let's have a look at it. At this point we have two branches how we can go. We can go left and learn about distributed compute and big data. And as a specific tool, we can pick Spark. Or we can go right, learn about SQL and databases. Here I would leave this choice to you because both paths are fine. Yes, I have my preference. For me, I would say it right away, I would go right for SQL and databases, but going left also has the benefit. And the benefit is that by learning distributed compute and big data, it matches and connects pretty well with the issue you had on the previous step, where you were not able to process big amount of data locally, because by learning about distributed compute you understand how actually we are able to process huge amounts of data. So if you prefer to build up on your small projects, then go left for distributed compute and Spark, but we'll get back to it later. So my preferred way now is to go right, and it's SQL plus databases. For SQL point, just learn the syntax, practice a lot, do exercises, watch tutorials, there are tons of them, and yeah, just get good at it, at just querying the data with SQL. Once you have like certain knowledge of SQL, you shouldn't like wait until you are a guru at SQL before learning about databases. I would say after a certain point, after you're good enough at SQL, at like solving some tasks with it, of querying data, it's time to learn about databases. Learn about relational databases, NoSQL databases, what are the differences between relational and NoSQL databases, why would you choose a relational database in this situation, and why NoSQL database in that situation. Data modeling in RDBs, like relationship between tables, one to many, many to many, and so on, normalization, data integrity, all that kind of stuff falls into the databases section. And this is a good point because it's a strong foundation that you need 100%. Yes, it doesn't link to our previous point as good as distributed compute and Spark, but still, regardless, this is a separate point, but a foundational point that is crucial. So let's move on. And after you are good with SQL and databases, it's time to learn about data warehouses. What are data warehouses? Why do they exist? What types of processing exist? Online transactional processing, OLTP, versus online analytical processing, all up. And this is tied directly to the concept of data warehouses. Just to drop some names here, the data warehouses that are popular now and that I have used personally a lot are BigQuery from Google Cloud and Snowflake. So yeah, just pick any of them and play around with them. You can even load the data that you were not able to process at pandas and polars step into the data warehouse, and I'm sure you'll be able to process it there with SQL. And the next step in this branch is actually the first step on the left: Spark, distributed compute, and big data. So here is my reasoning why I have put it like that. With data warehouse, you learn that you are able to process vast amounts of data, but you might lack some theory about how does it actually work, why data warehouses are able to process these amounts of data. And this is tightly coupled with distributed compute, because distributed compute is actually the reason why data warehouses and why technologies like Spark are able to process huge amounts of data and what we call big data. So here you will learn the theoretical concepts like master-slave architecture, about distributed storage, about distributed compute, about scaling vertical and horizontal, and how does it actually work. Why did I not include distributed compute into the data warehouses block? Because I feel like with Spark you can get a clearer understanding of it. I feel like data warehouses abstract a lot this distributed compute component, but with Spark, and when you learn about Apache Spark, you'll be kind of forced to have a clear understanding of distributed compute, because without that, you wouldn't really understand Spark. So that's why it's a separate block. And actually here you can come back to your initial data processing project with bigger amount of data that you were not able to process locally, and do it with Spark. Now I'll open the left side, and as you can see, it has the same blocks as the right side, but just arranged differently. And this is why I was saying that it's fine. It doesn't matter which side you choose, just a different order. So my preference was this order, but it's absolutely fine if you go, if you choose the approach on the left. Cool, so what's next? And next we have a crucial data engineering concept, the thing that data engineers are actually hired to build, and this thing is called ETL or ELT data pipeline. You'll learn about the concept of ETL and ELT, but these are actually just theoretical concepts that will take you like several hours to understand them. But it all doesn't matter until you actually create and apply your knowledge. And that's why at this stage we have a Milestone project. So my suggestion to you is to create ETL pipeline, extract, transform, load pipeline in some cloud. Choose whatever you like. You have 3 huge vendors, so just choose the one that you like and build an ETL pipeline there. I don't want to dive very deeply into the details of what that project might look like, but once you read about ETL and ELT, you can just either come up something by yourself or just Google ETL ELT projects in the cloud, and you'll get some ideas for inspiration. I'm 100% sure. Because you're already familiar with the concept. So just take data from one place, transform it in a certain way, and load it to wherever, to a database, or maybe at this stage it should be a data warehouse probably. And yeah, then just leave it there, query it, analyze it, and do that kind of stuff. And once you complete this milestone project that you did by yourself, I think it's a good time to start applying to positions in the companies that you like, looking at the job requirements, and maybe if you see certain technologies that you lack, like in every job position they want this technology and you don't know it, then go and learn it. It's fine. But I wouldn't wait. I would start applying already at this stage. And also, of course, keep learning. What I mean by keep learning, it's not the end of the roadmap, but it's a pivotal moment, I would say. Because after that, in my opinion, we have self-contained knowledge nodes, essentially knowledge nodes that are not really connected to other places, and you can learn them independently. But don't get me wrong, the fact that they are not in the main part of the roadmap, it doesn't mean they are less important. All of the nodes here are very crucial concepts, and I would say you have to know, you must know all of them and understand them very well. So we have here 7 separate knowledge nodes, topics. Of course, these are not all of them, but these are the ones that I chose and the ones that I think are very essential, but you already have chances to get an entry-level junior position at this point before you start learning them. But don't postpone it. Once you're finished with your milestone project and started applying to jobs, go directly into learning these points. I'll very briefly run through the notes that we have here so that you have a full picture. The one on the left, it's not the first one, they are not ordered, but just the one that is visually the first one, orchestration with Airflow. Airflow is the specific, very popular tool for orchestration. That's why I put it right here. You might need orchestration when you have to juggle data from many data sources and process data for each of them slightly differently. You most likely need an orchestration tool for that. Next point, APIs, application programming interfaces, a topic that is actually coming from a web domain, but regardless, as a data engineers, we need to be familiar with APIs and actually be very good with them, because we often have to integrate with APIs, and we also need to be able to build one to expose our data to consumers. So despite the fact that it's a web concept, we actually need to be good at it as well. Cloud. Not much to say here, you probably know it without me. Almost everything nowadays happens in cloud. Data is stored in cloud, data is processed in cloud, and you build your ETL and ELT pipelines in 99% of the cases in the cloud. So obviously you need to be good at it, and the better you know the cloud, the more valuable employee you are. There are 3 top providers: Azure, AWS, and Google Cloud. Pick one and learn about it. You probably have already some knowledge about the cloud from the Milestone project, but this is such a huge topic that you can learn it for a very, very long time. Yeah, it's better to get started as early as possible. And on the bright side, clouds are like programming languages. So once you are good with one cloud, once you know the concepts, you'll be able to pick up another cloud and get a grasp of it very quickly, because the concepts are the same. Data architectures. This note is purely theoretical. You learn about existing data architectures available. Some of them are older and time-tested, like Kimball, Inmon data architectures. Then some newer concepts like Data Vault and Data Mesh, which is very popular nowadays. Learn about each of them either with videos, articles, or maybe pick up some book that covers maybe all of them or some of them. But it's definitely a beneficial thing, and if you want to grow as a data engineer, that's something that you need to know. And this one is actually connected with the data modeling. This note is theoretical plus practical. So we have a concept of data modeling and the specific tool that is extremely popular now, dbt, and great tool. We also use it. You can model your data and run transformations with dbt plus certain data warehouse. Why is it connected to the data architectures node? Because low-level data modeling concepts like star and snowflake schemas are actually coming from one of the data architectures in the list. So these two are kind of related, but you can start with data modeling and then go deep into the data architecture, or otherwise, like whatever you prefer. Streaming and batch processing. These are 2 distinct ways of how your system can process data, and depending on your workload, like streaming or batch processing, you need to build your system differently and to use different tools. So this is also a crucial note. Then query optimization techniques. These are the techniques that you can use as a data engineer to optimize your database for certain workload. It includes using indexes for faster retrieval, data partitioning, replication, and sharding. These are actually ordered in a way of how I would suggest you to learn these concepts. And also I'll mention that it's mostly related to relational databases. So these two can go together, but I wouldn't learn query optimization at this stage because I feel like it's too early. I think it's more beneficial to learn query optimization right here. So it's not just a mistake that I didn't put it here. This is actually intentional. So learn about query optimization downstream. And this is it. This is the whole roadmap that I came up with based on my experience in the industry and how I would learn data engineering if I had to start now. If you found this video helpful and maybe even enjoyed it, I hope, then subscribe to the channel for more content like this. And write in the comments what do you think about this roadmap, and if you start executing on it, also write your progress. I'd be very excited and interested to know how it goes for you. With that, thanks for watching and see you in the next one.